start. It will start soon. Yeah, I think this is sufficiently large. Problems which were discussed yesterday. I think this was the problem which I'm talking about. So this was the problem. Let A equal to 1, comma 2, comma 3, comma 4, comma 5 R be a relation on A cross A such that A comma B will be in the relationship with C comma D if and only if you are getting this condition satisfied, A plus B equal to B plus C. We have already proven that this relation is an equivalence relation because it is reflexive, symmetric, as well as transitive. Further, I think this, I promised yesterday that we will consider this in tomorrow's session. So let us go for this. What do you mean by equivalence class? We need to find equivalent class of pair 2, 5 in the context of relation R. This I have to compute. I do not know what it will be. First of all, I will try to write it in terms of some unknown pair x comma y. It will be a unknown pair x comma y which is in relationship with 2 comma 5. Okay, I try to get x comma y such that x comma y relationship with 2 comma 5. Alternatively, we should write like it is. Okay. So that you will not get confused. 2 comma 5 x comma y belongs to R. Are you getting the definition of equivalence class now? At least you will have plenty of pairs on car. Okay, if 3 comma 6, yes, it is correct. You will have 3 comma 6. But I am giving you generalized idea how to compute pairs which are in relationship with the 2 comma 5. So this is the meaning of equivalence class of 2 comma 5. Equivalence class of 2 comma 5 in the context of binary relation R, which is equivalence, is all pairs x comma y such that 2 comma 5 comma x comma y belongs to R. What is the meaning of it? How can we further simplify it? This is equivalent with all x comma y such that 2 plus x is equal to 5. Sorry, 2 plus y is equal to 5 plus x. Are you getting my point? And this should belong to, okay, obviously this will belong to R if this condition is satisfied, otherwise it will not belong. Are you getting? Am I clear? At least say yes or no. If this is clear, then only we can go for the further solving. No? Yes, if this is clear. Okay. Now what is asked? Okay. Let us try to further simplify it in terms of x and y because we do not know what x and y is. Okay? So I will write this. This is equivalent with x comma y such that we will write it like, let us say, x minus y equal to, what will be x minus y? Y goes there and 5 comes here, so I will have minus 3. Or I can write it like I am just simplifying, okay, nothing else. I can write it like y equal to x plus 3. Okay, for all x comma y belongs to A. A is given. We are defining a relation based on E. So this is just a simplification for finding out what we exactly want. Just observe. I have simplified this equation and I am getting y is equal to x plus 3. Some of you may write x is equal to y minus 3. Sorry, minus x equal to y. No, x equal to y minus 3. You can write it like this. We have to now what? We have to find only those values from A. Which are the values present in A on which relation R has been defined 1, 2, 3, 4, 5. So while selecting x comma y, I need to select them appropriately. Using this condition, y equal to x plus 3. So if I put 1, what will be the value of y? 4. So this will be first. Okay. Whether 1 and 4 are present in A? Yes. If I put y as 2, what will be, sorry, if I put x as 2, what will be y? 5. It is present. Okay. If I put x as 3, what will be y? 6. Do we have 6 in our given relation? Let us check. Do we have 6? No, we are having elements up to 5, so I cannot consider that 6. Okay. Pair will not be present. Okay. Further to this, if I put x as 4, and nothing will come. Okay. 1 comma 4, 2 comma 5. Okay. Further to this, which other pairs we can have? Y equal to x plus 2 or x equal to y minus 3. What is? If we say x equal to y minus 3, we will go in reverse. X equal to y minus 3. So I will have 5 comma 2. Can I have 5 comma 2? This is x equal to, no, 2 comma 5. Any other apart from this? Any other that you observe apart from this? I think there are no other pairs apart from this. Onkar Lokhande. Onkar is saying there should be pairs 4 comma 7 and 3 comma 6. Onkar, observe, we are taking these elements x and y from where? We are taking x and y from A. How many elements are present in set A? We are having only 5 elements, 1, 2, 3, 4, 5. So you cannot take a pair 4 comma 7 or 3 comma 6 because 7 and 6 are not belonging to A. So you will have only these two pairs. Are you ready? 1 comma 4 and 2 comma 5. So what is the equivalent class of 2 comma 5? 1 4 2 5. Let us cross check. If I make a pair 2 5 1 4, it will be, the summation will be 2 5, 2 plus 4 6, 5 plus 1 6. Okay. 2 5 2 5, 2 plus 5 7, 5 plus 2 7. So this is the answer, equivalent class of 2 comma 5. I hope you have understood this. In case of problem, let me know. Do you have a problem? No problem. As such. Fine. So example number 12. We will take it a little bit simpler so that you will not find it every time I'm taking out only. Let r equal to x comma y such that x minus y is odd integer, comma x comma y belongs to z plus set of positive integers, that is given. Okay. You need to identify which properties are satisfied by R. Let me know. So whether R is reflexive, whether R is symmetric, irreflexive, whatever, tell me. I'm taking out all those examples which have been frequently asked in university question papers. Okay. Let A equal to 1, comma 2 up to 6. R equal to x comma y such that mod of I minus j is equal to 2. Fine. And R bar, I'm not having that symbol, so I'm writing negation of R. Then find R converse find domain of 2 and properties of above relation. Which are the properties that are satisfied that you have to compute. Yes, any problems so far? All of you are trying and solving. I have given you two examples. Okay? Be quick and let me know your answers. Example number 14. Let x be a set of integers 1, 2, 3 up to 7. R be a relation defined on x such that it is all pairs small p comma small q such that p minus y is. I think I have taken this example yesterday. Okay, so I will just make it different. Certainly, such that p minus q is less than equal to 3. Check if it is equivalence binary relation that you need to do. Can you reply now about example number 12? Which are the properties that are satisfied by this? Yes, any answers? No answers? Okay, at least tell me the pairs we will write over here. What are the elements of R? Can you tell me? Whether R will have 1 comma 1? Whether 0 is odd? No. Okay. So we will not have 1 comma 1 that you are saying. Okay. Next, let us say 1 comma 2. What is the difference? 1 minus 2 minus 1. Whether that is odd minus 1. Minus 1 is odd. Okay. So can we take that 1 comma 2 pair in our relation? Can we consider it? Here, for solving this type of examples, you can work by assuming the given set. So I am showing you now the solution which doesn't make use of any counter examples. We are not considering the actual pairs, but we are using the properties of every relation. A binary relation is said to be reflexive if I am observing a pair x comma x present in the relation, okay, for every x belonging to z plus. So as per the given property, okay, for x comma x, x minus x is 0, is not odd integer. Therefore, x comma x doesn't belong to R. Hence, R is not reflexive. If it is not reflexive, whether it will be reflexive, I am not taking any pair, okay, like 1 comma 2, 1 comma 3. I am taking in terms of x and y only. Whether it will be irreflexive. When to say a binary relation is irreflexive? If no pairs of self loops are present. Okay. As x comma x for all x belongs to z plus doesn't belong to R, R is irreflexive. Are you getting my point? Are you getting the solution? At least you can say. In a similar manner, we will check for symmetry. When to say a relation is symmetric, it will be symmetric if we are having both the pairs x comma y as well as y comma x. Are you ready? So, if I want x comma y in a relation, I must have x as odd. Okay. And if I take y comma x, I must have y minus x as odd. So you could observe x minus y is odd. It could belong to your relation as we are defining a relation on set of positive integers. But if I take y comma x, it will result in negative value. So that negative value must not be, is not present in the Cartesian product of z plus. Remember that we are defining a relation. That relation is nothing other than a subset of z plus cross z plus. So we will have only positive pairs. We are not going to have this y comma x anywhere. So relation is not symmetric. Odd doesn't belong to R. Okay, hence R is not symmetric. You can take any counter example for cross checking. No? Asymmetric? Yes, it is. R is asymmetric. Why? Because no self loops. We have observed as it is not reflexive. No self loops and not symmetric. Hence asymmetric. Antisymmetric? Not. This is yes. It is asymmetric but not antisymmetric. Let us check for transitive. Let us check for transitive. Whether it is transitive? Whether it is transitive, can you now tell me based on pair? Let us say we are having pair x comma y and pair y comma z, and we also have a third pair x comma z. In terms of this, can you tell me? For having a pair x comma y, what is the condition? X minus y is odd. that you should satisfy. Okay. For having a pair y comma z, y minus z is odd. And for third, here you should have x minus z to be odd. Whether it is transitive. We cannot say it is as the transitive. If you put any sample points over here, let us say x is 1, y is 2, y is 2, z is 3, and 1, 3. Okay. If I say, definitely I have to take like, for example, let us say x is 2, y is 1. We are taking to take x is 3, y is 2, and z is 1. Let us work for this. If we take like this, 3 minus 2, okay, 3 minus 2, 1. Next is 2 minus 1, 1, okay, and 3 minus 1, 2. So obviously it is not transitive. You can watch, okay, not transitive. You can tell me any counter example wherein you are finding it as a transitive. So what is our conclusion? This example, okay, this relation is irreflexive. It is asymmetric only. So R is irreflexive and asymmetric. Remaining properties are not satisfied. Now, can you tell me, for example, number 13? Yes. Yes, Sunny Goi has given the answer. Very nice. Okay. What he has said? So he have told us about all the pairs. I will simply copy down these so that we will not have any. Oh, he's saying what? These are the pairs present. So whether others are also getting these many pairs only, or there is addition or duplication of any pair in whatever he has written, are equal to this. This he has given. Figure. These are the pairs which are being identified. Okay. In each pair, you could observe absolute difference should be 2. 1, 3, 2, 4, 3, 5, 4, 6, and any pair. Okay. We have to select the elements for forming a pair from set A, wherein you are having elements from 1 to 6. Okay. So he is saying what properties? He is saying R is not reflexive. Yes, 1 minus 1 is not 0. 2 minus 2 is not 0. Like that. It is not reflexive. Okay. If it is not reflexive, obviously it will be irreflexive. Are you ready? If it is not reflexive, that means any pair is absent. Okay. Then you would have irreflexive. So R is irreflexive. It will be symmetric, I guess, because absolute difference is given 1, 3, 3, 1, yes, 2, 4, 4, 2, and everything. Okay. R is irreflexive. R is symmetric. Further, if it is symmetric, it will not be asymmetric. Whether it is anti-symmetric, whether it is anti-symmetric, no, it is not anti-symmetric because self loops are absent, and we could have either 1 comma 3 or 3 comma 1, but not both. But we are observing both are present. Whether this is transitive, whether this one is transitive, no, this is not transitive as well. So only these two properties are satisfied. R is irreflexive and symmetric. Now, can you tell me what will be R bar and R raised to C? R bar, can you find the complement of R? I have taken this during our starting of binary relations. Okay, how to compute negation or complement of a binary relation. What do you mean by converse of a binary relation? Okay, before going for that R bar and R converse, you have been asked D of 2. What is the meaning of D of 2? Domain of 2. Domain of 2. That means 2 is the element which should be present on the right hand side of comma that is given. So what are the elements which are related with 2? That is asked. Domain of 2. So what is domain of 2? 2 should be present on the right hand side of comma. Okay, so I am observing 4 is related with 2. 4 is domain of 2. Any other from 4? No. And if you have been asked what is range of 2, what will be your answer? Range of 2 means elements which are related with 2. Range of 2 is 4. Is it clear? If I ask you what is range of 4, can you tell me the answer? What is range of 4? 2,6. Very nice. Range of 4 is 2,6. Okay. And what will be domain of 4? Domain of 4. I think 2,6. Very good. So in okay, here we are getting both same, but remember that if you have been asked to compute domain of particular element, you will be looking for all those elements present before comma for domain for the corresponding element. Okay? And for range, I will be checking out all those elements which are present after comma. Okay. Yeah, fine, fine, fine. So Sharan is saying 2. Just observe, we will have 2 and 6 as well. Range of 4. Okay. So 4 is related with 6, 4 is related with 2. So we are going to have both 6 as well as 2. That I have written. Shivshar. Viraj has computed R converse. It is very easy to compute R converse because you need to simply reverse the pairs. So what will be in R converse? R is to C. So we would have 3 comma 1, then 4 comma 2, and so on. Okay. We will have so. So simply reverse. A comma B becomes B comma A. 2 4 4 2 3 5 5 3 4 6 6 4 and so on. Main question is what is R bar? None. None? No. It is not phi. No, it is not phi. How come it will be phi? Those who are saying phi, we are defining a relation R on what? We are defining relation R on A cross A. So how many pairs I will have in A cross A? I will have everything. 1 comma 1, 2 comma 2, 1 comma 2, and so on. How many in total? 6 6 are 36 pairs we are going to have. Out of that, we have got 8 pairs in relation R. So the cardinality of R bar. What is R bar? It is all A comma B such that A comma B is not present in R. So cardinality of this relation will be 36 minus 8, which is coming around to be 28. You are going to have 28 pairs present. Okay. Those who have given the answer as pi, try to recall the definition of R complement. Ready? Complement will have all the other pairs except these 8. Okay. Going ahead, tell me quickly whether this is equivalence relation or not. Okay, first of all, tell me what are the pairs present in R. Be quick. So, can we have 1 comma 1? Yes. Can I have 2 comma 2? Yes. Can I have everything? Yes. It will result in 0. So, it is reflexive. Okay. Further, I want p minus q less than equal to 3. So, I am saying 1 minus 1 is 0, 2 minus 2 is 0, and so on, less than equal to 3. So, if I consider a pair 1 comma 2, what is the result? 1 minus 2 is minus 1. Minus 1 is less than equal to 3. Yes. If I take a pair 2 comma 1, yes, again the result is 1 is less than equal to 3. No? If I take a pair 1 comma 3, what is the result? Minus 2 is less than equal to 3. If I take a pair 3 comma 1, yes. I'm not saying dot dot dot. So you can have pairs like this. Let us check for transitivity. Okay, how can I check for transitivity? So let me take some pair like 1 comma 2. Let me take a pair like 2 comma 4. So can I have pair like 1 comma 4? Let me cross check. I'm saying 1 2. The result is p minus q minus 1 less than equal to 3. Perfectly fine. 2 4 minus 2 less than equal to 3. Again 5. 1 4 minus 3 less than equal to 3. Again 4. So 1 to 2, 2 to 4. We are getting 1 comma 4. So the given relation is equivalence relation as it is reflexive, symmetric as well as transitive. Whether all are getting my point? Should we proceed? Yes, fine. Example number 50. This was asked during the last examination. Let A equal to set of lines in plane, geometric plane. Set of lines in geometric plane. X comma y are let me define directly a relation. R be a relation such that it is having pair x comma y such that x is perpendicular to y. Check if R is equivalence. To R, and again on the basis of same I am defining R1. R1 let us say A comma B. Such that A is parallel to B. Check if R1 is equivalence. These are the questions that you have to try. Whether it is equivalence, which one is equivalence? R or R1 or both? And how? R1 is equivalence. Whether R is equivalence? R is equivalence or not? No. Why? How you have proven? Your answer is correct. Okay. So solution. So first, we will check for reflexivity. Reflexive. Okay. For reflexive, what I need? X comma X. So X is a line. Okay. Do we have every line perpendicular to itself in geometry? X is not perpendicular to itself. Okay, it is not perpendicular. It must have the angle 90 degree in between both. Okay, so you cannot have angle 90 degree between X and X itself. So how you are going to have it? Ready? I will to say, let me explain this with the help of diagram so that you will understand it clearly. Look. So let us say this is a line. This line is X. Okay. And I want to have another line X. Can we have such perpendicular possibility in case of line with itself? No, this is not possible. A line cannot be perpendicular with itself. So you are not going to have it. Okay. So this is not reflexive. So I will say not reflexive. You cannot have. Okay. Let us take for symmetric. Whether this is symmetric. Symmetric. So we will have two lines, X and Y. Let us say this line is X and this line is Y. Okay. X comma Y. This is represented using this. Can I say it in reverse? Y comma X? Yes. Because the angle in between both of the lines will not change. It will remain 90 degree only. So it is symmetric. Symmetric, yes. X comma Y as well as Y comma X, you can prove it. Okay. If you say X is perpendicular to Y, you can say Y is perpendicular to X. Let us check for transitivity. For transitivity, we need to show X comma Y Y comma Z then we must have X comma Z belongs to R. Whether this is holding true, let us check. Let us say this one is X. Let us say I am saying this one is Y. And we are having other relation. Y is perpendicular to Z. So let us say this one is Z. So what is the relationship in between X and Z? What is the relationship in between X and Z? X is parallel to Z and we want X to be perpendicular to Z. So that relationship is not satisfied here. You could observe X is in parallel with Z. It is not in perpendicular. So hence it is not transitive. So in examination you are supposed to draw these diagrams, okay, for proving out why this is not transitive. And as The two properties, reflexive and transitive, are not satisfied. I will say that R is not equivalence. R is not equivalence. Okay. And as per the geometric theory, we know that every line is parallel to itself. So I can say it is reflexive. If I take A comma B, A is parallel to B. Obviously, you would have B is parallel to B. Okay. And for transitivity, I am now talking about R1. Okay. This I talked about R. Now let me talk about R1. Let me take new. Let me discard it. So I am saying this one is X. X is parallel to Y. So we are saying this one is Y parallel. Y is parallel to Z. The third one. So whether X is parallel to Z, yes, if X is parallel to Y, Y is parallel to Z, obviously you are going to have a relationship in between X and Z, which is parallel. So it is transitive. I am talking about R1. Okay? So R1 is reflexive, symmetric, as well as transitive. Hence, it is equivalence relation. Is it fine? Is it fine? Should we proceed? One last example till I take your attendance. Shall I give you another example for trying? Can you reply in the chat box? So one last example for this properties. Tomorrow I'm going to start with next point. And be aware, I have scheduled objective examination on permutation, combinations, and binomial coefficients tomorrow at 4:30 in the evening. I repeat, we are having objective examination of 25 marks tomorrow at 4:30. The syllabus is counting theory, unit number 2. Have you got my point? Tomorrow you need to appear for exam. It is compulsory. Example last 16. Let equal M of R. Matrix of R is given. I do not know exactly we are going to have such equal to question will be very simple. So it is equivalence and equivalence process and also find rank of equivalence. This is the example. Take a quick snapshot. Have you taken the snapshot? Okay. I hope you have taken. You have to solve it. So if you have taken the snapshot, that's it from my side for today. Let me stop recording.